Let's start talking about even and odd properties of trig functions. So you've already learned in algebra and in pre-calculus what even and odd functions are like. So let's start with that idea. So if you think back to what we talked about before with even and odd functions, to figure out algebraically if something was even or odd, we would plug in a negative x. And if we got out the same exact function, the original function, we knew that the function was even. And if we plugged in a negative x and we got out the negative version of the function, we knew that that function was odd. So we did these with lots of different polynomial functions. Now we can do it also with trig functions. So instead of plugging in a negative x into these trig functions, I'm going to plug in negative theta. It's the same idea as plugging in negative x. I'm either going to get back the original function as is, or I'm going to get the negated version of that function. And I'll talk about why this is in a little bit. So I'll come out right up front and tell you what these properties are, and then we'll talk about why they are that. So sine of negative theta gives you negative sine of theta. So when you plug in negative theta, you get out the negative version of what that would have been when you plugged in positive theta. All right, cosine of negative theta, if I plug in negative theta, for example, negative 45, I get back cosine of theta. So had that theta not been negative, the example I gave was negative 45, so regular theta would be positive 45. So cosine of negative 45 is the same as cosine of 45. Okay, cosecant, the reciprocal of sine, is going to give you the negative version of that. So for example, cosecant of negative 45 degrees is equal to the negative version of cosecant of 45 degrees. All right, secant gives you the original thing. So if you plug in a negative angle, for example, negative 45, you'll get back secant of 45. So it's the same value. Okay, tangent is negative tangent. So when you plug in negative theta, you get out the negative version of what it would have been with the original theta. And cotangent is also negative. Okay, so we'll kind of delve deeper into this and make more meaning of it in a second. So here are just these identities, but we'll talk about what they mean in just a second. So notice, sine of negative theta, cosecant of negative theta, tangent of negative theta, and cotangent of negative theta all have negative outputs. Okay, so these four trig functions that I'm putting in a box here, if I get out the negative version of the original function, we know that these functions are odd. So these are odd functions. Okay, these two here are even functions. If you remember in the homework, number 8 was the question that talked about the functions that are even and odd. There's your list of even and odd functions. And when we get into graphing these, you'll see it graphically as well. Remember, even functions are going to be symmetric to the y-axis, and when we graph these, you'll see that. And odd functions are going to be symmetric about the origin. When we graph these, you'll see that as well. So as always, I like you to understand what these actually mean instead of just memorizing this. So here's a visual representation of why this is the case. So we're going to start by talking about sine of theta. Let's just choose a random theta. How about sine of pi over 6? So we know that pi over 6 is this little short angle in quadrant 1. That's not actually short enough. There, that's pretty good. So there's pi over 6. So sine of theta, just thinking about sine in terms of it's the y value in the ordered pair, we know that sine of pi over 6 is positive 1/2. Okay, we're really just going to focus on the fact that it's positive though. Okay, so what happens if I graph sine of negative theta? If my theta was pi over 6, negative pi over 6 is in that same position. It still is that short little angle, just barely off the x-axis, but now it's in the negative direction. Okay, so we said that in quadrant 1, sine was positive. Down here in quadrant 2, sine is negative. So you can see why these are opposite versions of each other. So that means that sine of negative theta is negative sine of theta. There's that rule kind of coming to life. So in other words, if we plug in negative theta, we get out the negative version of what the original theta was. Okay, so now let's do this for cosine of theta versus cosine of negative theta. So let's talk about pi over 6 again. So we've got pi over 6, positive pi over 6, cosine is root 3 over 2. What about cosine of negative pi over 6? Down in quadrant 4, the y value was negative. So remember when we did sine, we switched the value. But what about for cosine? Isn't cosine still positive in quadrant 4? So cosine went from being positive root 3 over 2 for pi over 6 versus for negative pi over 6, it was still positive. So did that value change? No, it didn't change. So again, you can see that rule coming to life. Cosine of negative theta doesn't give you the negative version, it gives you the same exact value. So let's talk about tangent. Let's do tangent of pi over 4 because that's a really easy one to do. So tangent of pi over 4 is positive 1. What about tangent of negative pi over 4? So down in quadrant 4, we know that x is positive and y is negative. So y over x is also going to be negative. So tangent's positive in quadrant 1, negative in quadrant 4. And I know we've talked about this before. So that means that if I'm plugging in negative theta, I'm getting out the negative version of what tangent of theta would have been. Okay, and I just realized that I made a mistake going back and looking over my work here. So cosine of negative theta, when I plugged in negative theta, I wrote negative cosine of theta. I hope I didn't say that out loud, but this should be positive cosine of theta here. So we're going to scribble out that negative. Okay, so notice here these things came to life. Sine of negative theta was the negative version, and so was tangent. Okay, but when we plugged in negative theta for cosine, we got back the original thing. So there's these even and odd identities coming to life. Okay, so you may be wondering, why are we doing this? We already knew how to evaluate things like sine of negative pi over 6, cosine of negative pi over 4. We've done things like that. You had us doing those things in the homework. And the next section in the notes, you can do that using skills that you guys already have. You can do things like sine of negative 30 degrees, thinking about where is this located and what family is this. To do cosecant of negative 45 degrees, you can say, what family is this? Where is this located? Cosine of negative 2 pi over 3, what family is this? What quadrant is it in? You've already done things like that, but I want you to use this idea of even and odd properties just to practice this, and then you can kind of check it based on what you already know. So go ahead and do that, and then I'm going to put the answers up on the video. So pause the video now, see if you can do these using the even and odd properties. So for example, sine of negative theta. Is that sine of theta, or is it negative sine of theta? So for sine of negative 30 degrees, hopefully you thought to yourself, okay, I know that sine is an odd function, so I know that sine of negative 30 is the same idea as the negative version of sine of 30. Okay, so we can evaluate sine of 30, which is in the pi over 6 family. It's positive 1/2 up in quadrant 2 at 30 degrees, but we want to negate that value. And you also know, if you thought of it in terms of what you've already done, that sine of negative 30 is in the pi over 6 family, and it's down in quadrant 4. So you know that the y value is negative there. So for cosecant of negative 45 degrees, hopefully you first thought to yourself, I know that this is an odd function. It's the reciprocal of sine, so it has the same properties as sine does. So I know that this is going to be the equivalent of negative cosecant of 45 degrees. So we know that cosecant is the reciprocal of sine, and we know that sine of 45 degrees is root 2 over 2. If we flip that over, take the reciprocal of it, we get the square root of 2, and now we just need to negate it. And if you use the properties, the skills that you already know to evaluate this, you will get the same answer. So I'm showing you two different ways that you can do this now, using even and odd properties and using those skills that you already have to kind of work together to check yourself. So for cosine of negative 2 pi over 3, hopefully you thought to yourself, this is even, so I know that it's going to be the same as cosine of 2 pi over 3. So I'm going to get the same value out because it doesn't matter if I go up or down because cosine is going to be the same. The x value will be the same. So cosine of 2 pi over 3, that's in quadrant 2, it's negative 1/2. If you thought of this in terms of what you already know, Cosine of negative 2 pi over 3 is down in quadrant 3. Cosine is still negative in quadrant 3, though. And the last example, tangent of negative pi over 6, that function is odd, so you know that this will be the negative version of tangent of pi over 6. So tangent of pi over 6 is root 3 over 3, and we just need to negate it. All right, so there's the summary of these kind of using unit circle values. We can also use these properties to do non-unit circle values. Okay, so this is why I actually am teaching you this. Not so that I can make your life more confusing with the unit circle, but sometimes we have to use these. We have no choice. So now I'm going to show you an example where you have no choice but to use even and odd properties. Alright, so in this example I give you tangent of theta is 2 over 3, and I want you to find tangent of negative theta and cotangent of negative theta. So you're not only going to have to use even and odd properties here to do these functions for negative theta, you're also going to have to use this idea of reciprocal identities, as in tangent and cotangent are reciprocals of each other. So once I find this, that means I can also find this. Alright, so let's get started. If you wanted to, you could first think about, what this triangle would look like. You know that your y value is 2, and you know that your x value is 3 because you know that tangent is y over x. But that's not really super helpful, and you don't really even need to draw a triangle here. All you need to know is that tangent of negative theta equals negative tangent of theta because it is an odd function. Okay, so hopefully you can see why we have no choice but to use even and odd properties here, because this is a non-unit circle value. So tangent of negative theta is the negative version of tangent of theta. So that just means I need to negate that value that they gave me for the original tangent of theta. So all I had to do was negate this because this was an odd function. Okay? Cotangent of negative theta is, cotangent is also a negative function, so that means cotangent is the negative version of cotangent. So looking at this, cotangent would be the reciprocal of this value, so 3 over 2. All we need to do is negate that. We could have also gone from our final answer for tangent of negative theta and just flipped it over for cotangent of negative theta. So we're using this idea of even and odd functions. Since both of them are odd, we could flip that over.